All right, guys, in this video, we're going to go through a bunch of different ratio problems and looking at how to apply ratios in kind of different circumstances and scenarios. So here we go. So the first question says, a map has a scale of 1 to 250,000. Two cities are shown as being 3 centimeters apart on the map. So what is the actual distance between the two cities? Okay, so when it comes to ratios, technically there's no units, but when we say 1 to 250,000, it's either no units or it's the same unit. So for example, for every 1 centimeter on the map, it's going to represent 250,000 centimeters in real life. So here we've got 3 centimeters on the map. So in real life, it's going to have to be 3 times that. So it's going to be 750,000 centimeters in real life. Now we need to convert this to kilometers. So I need to get this to meters, and then I need to get this into kilometers. So the centimeters to meters is divide by 100, and then meters to kilometers is divide by 1,000. So I just need to go do that twice. So 750,000 divided by 100 and then divided by 1,000. That gives 7.5 kilometers. Here's the second problem, which is a capture-recapture one. Now this is also a rate and ratio topic. So a researcher captures 80 fish from a lake, tags them and releases them. A week later, they catch 50 fish and find 10 of them are tagged. So estimate the total population of fish in the lake. All right, so there's a couple ways to look at this. One way is just to memorize the formula on how they do it. The other method is to just think about, you've got two scenarios. You've got the capture and you've got the recapture. Now in the capture scenario, it's always how many captured and tagged. So in this case, it is 80. And in the denominator, it's going to be the estimate for the total population. So here is the estimate for the total population, which I'm going to call X. So X at the bottom. And that's always equal to what's recaptured. So how many are captured and tagged? Well, 10. And how many fish were captured in that mix? Well, that's going to be 50. And now all you got to do is just solve this equation. So I'm going to cross multiply. 80 times 50 is 4,000. 10 times X is 10X. Divide both sides by 10, so X is equal to 400. All right, so here's the next problem. A container contains a mixture of juice and water in the ratio of 2 to 5. If there are 10 liters of juice in the container, how much water is in the container? Okay, so what do we have? We got, the container holds a mixture of juice and water. So we got J and W in the ratio of 2 to 5. If there's 10 liters of juice, how much water is in the container? So I'm gonna put 10 down here below it. 10 down here below it. Now, what I know is, right, now one way you can think about it is in terms of parts. So here you've got 2 plus 5, that's 7 parts. And so 2 over 7 parts, because there's 7 total parts, is going to make up 10 liters. But I'll take a little bit of a different approach. Another way I can think about it is how much bigger is 5 than 2? Okay, now clearly it is going to be 2.5 times. If you're not sure how to get that, just do 5 divided by 2. So for every 1 part of juice, there is 2.5 water. So if there's 10 parts of juice, there's going to be 2.5 times that amount. So 10 times 2.5, that is 25 liters. So 25 liters of water. Okay, question 4. So a sports drink is made up of mixing syrup and water in the ratio of 1 to 4. A large container has 10 liters of syrup mixed with 10 liters of water. If 5 liters of syrup is added, what will be the new ratio of syrup to water? Okay, so this one's a little bit more complicated than the next one, but let's set it up. So we've got syrup and water in the ratio of 1 to 4, like so. A large container, so in this large container here, has 10 liters of syrup mixed with 10 liters of water. Okay, so it's got 10 liters of syrup plus, 40 liters of water. Okay, so in total, there's 50 liters in here. This is syrup. This is water. If 5 liters of syrup is added, what will be the new ratio? Okay, so we're going to add 5 liters of syrup into here. So right now, the ratio is 1 to 4. So if we add 5 liters of syrup, it's going to be 15 liters and so 40 liters of water. So here we've got 15 liters of syrup. Oh, this is syrup and this is water. So now I just got to simplify the ratio, not too difficult. So, okay, so 15 to 40, divide both sides by a number that goes into both. So let's say 5. So 15 divided by 5 is 3. 40 divided by 5 is 8. So that's your new ratio, 3 to 8. Right, so here's the last question. A wildlife reserve has an area of 1,000 square kilometers. In a sample of 2 square kilometers, 25 animals are counted. So estimate the total number of animals in the reserve. All right, so I personally like to draw a diagram whenever I can to simplify things for me. So we've got some reserve which is 1,000 square kilometers. And in a little small area in here of 2 kilometers squared, there are 25 animals. Okay, so within the smaller square there is a little 25 animals. Now, what proportion of animals are in the 2 kilometers squared? Well, it's going to be 25 over 2. And we're trying to work out what the total number of animals are in this reserve. So it's going to be X for the number of animals over the total area. It's kind of like capture recapture. So now I can cross multiply. So 25 times 1,000 is 25,000. 2 times X is 2X. So divide both sides by 2, you should get 12,500. Done. All right, that's it for today. Really short video on a bunch of different examples using ratio questions. In a follow-up video, we'll do some more complex ones. Otherwise, thanks for watching, and I'll see you in the next one. Peace.